Welcome to The Explainer. Today, we're going to set the stage for solving some of your absolute most maddening electronics prototyping frustrations. Honestly, if you've ever felt like your hardware project just has a mind of its own, you are in exactly the right place. We're going to take a hard look at the physical realities of prototyping that trip up even the most experienced makers. It's a painful reality, isn't it? You know the feeling. You've checked your code 10 times. Everything is logically perfect, but your circuit only works when you physically press down on a wire with your thumb. Or maybe it randomly fails when someone just bumps the table. It's incredibly frustrating, but I have some really good news for you. The code isn't always to blame. Actually, one of the hardest lessons for beginners to learn is that the physical connections in your prototype are just as critical as the software running on it. Okay, let's dive into this diagnostic journey. Here's what we're looking at today. 1. The hardware prototyping trap. 2. The 22 versus 24 AWG debate. 3. Hidden breadboard pitfalls. 4. Signal and power limits. 5. Making custom jumper wires. And 6. Troubleshooting and next steps.
Starting right off with Section 1, the hardware prototyping trap.
So a solderless breadboard is an absolutely amazing tool, right? But it is not a permanent printed circuit board. It relies on these little internal spring contacts to grip your wires. And those contacts, well, they just aren't perfect. If you're experiencing symptoms like an I2C scanner that only finds your sensor sometimes, an OLED display that freezes up and shows random pixels, or maybe a microcontroller that abruptly resets the literal second you plug in a new module, you're likely caught in this hardware trap. These specific symptoms usually point to a mechanical hardware fault, like a loose connection or a voltage drop, rather than a software bug. Let's move on to Section 2, the 22 versus 24 AWG debate. First off, AWG stands for American Wire Gauge. It's just the standard system used to measure wire diameter. The most important thing to remember here, and this trips people up all the time, is that it works in reverse. A lower number actually indicates a thicker wire. Now, what's really interesting about this slide is the massive contrast between these two popular wire sizes. Users on Reddit were actively debating whether to use 22 AWG or 24 AWG for general breadboarding and power delivery under 3.5 amps. The 24 AWG wire is slightly cheaper, sure, but users report that it feels kind of thin and flexible. And because it's thinner, it doesn't stay gripped inside the breadboard's spring contacts very well. 22 AWG, on the other hand, is thicker and provides a much sturdier, far more reliable grip. This quote from a wild Redditor really hits the nail on the head regarding the community consensus. They say, "In my experience, 22 AWG solid wire is the best suited for most breadboards. Thinner wire tends to be a little too flexible, and thicker wire can jam in the breadboard." And they're absolutely right. If you go too thin, you get these maddening intermittent connections. If you go too thick, like trying to jam square header pins into those tiny holes, you actually permanently bend and ruin the spring contacts inside the board. So 22 AWG really is the sweet spot. All right, on to Section 3, hidden breadboard pitfalls. Now we're looking at the usual suspects. Take the power rails, for example. Those are the red and blue lines running down the sides of your board. Beginners naturally assume that if you plug power into the top, it just flows all the way to the bottom, right? Well, actually, many breadboards have an internal split halfway down. You might literally have half your board completely unpowered without even realizing it. Then there's the center gap, which completely disconnects the left and right sides of a row. Add in worn-out contacts, oxidized pins that have just been sitting in a drawer for years, or simply inserting a wire one row off because, let's be honest, it's hard to see in there. Combine all that, and you have a perfect recipe for phantom hardware bugs.
Which brings us to Section 4, signal and power limits.
And this brilliantly illustrates how specific electrical symptoms map directly to their root hardware causes. If your I2C devices are disappearing, it's often just because your messy, long wires are adding way too much capacitance or resistance. Or if your high-speed SPI display is showing random pixels, that's because those long jumper wires are literally acting as small antennas, picking up electrical noise from the room. Crazy, right? The immediate fix here is to shorten your wires and keep your signal paths as clean as possible. Now, this is a massive takeaway. Breadboard contacts simply cannot handle high current. When you try to power a servo, a DC motor, or a huge LED strip right through those tiny metal clips, they create resistance, and that leads to a massive voltage drop. Suddenly, your microcontroller doesn't have enough power to stay on, which causes it to randomly reset. You should always power your heavy loads directly from your power supply, definitely not through the breadboard.
Okay, moving to section 5, making custom jumper wires.
So if you don't want to buy a brand new spool of 22 AWG solid core wire, Make Magazine actually highlighted a really clever DIY approach. You can upcycle materials you might already have sitting around the house. Old telephone wires, clipped legs from old LEDs, maybe a little bit of heat shrink tubing. All of this can give you a cheap, flexible alternative to standard jumpers, and it lets you create the exact length you need for a super clean circuit. If you're using solid core wire, here's the quick step-by-step process. First, cut your wire to the length you need, but be sure to leave about an extra 3/4 of an inch. Second, use a gauged wire stripper to pull about 1/4 to 1/3 of an inch of insulation off each end. Finally, take some needle nose pliers and bend the exposed ends down at a crisp 90-degree angle so they sit perfectly flush against the breadboard. So the crucial point here is this warning. Do not nick the metal wire when you're stripping the plastic insulation. If you use a generic stripper and squeeze just a little too hard, you create a tiny cut in the copper. That nick weakens the wire, and eventually it is going to snap off right inside the breadboard hole, permanently block that contact, and absolutely ruin your day. Finally, section 6, troubleshooting and next steps. When things go wrong, and they will, here is your actionable checklist. First, do the wiggle test. While the project is running, gently wiggle one wire at a time. If the behavior changes at all, you've found a mechanical fault. Second, don't just measure voltage at your power supply. Measure it directly at the pins of your failing module so you can actually catch any voltage drops across the breadboard. Third, if you're totally stuck, just rebuild the circuit in a completely different, unused area of the breadboard to rule out a damaged spring contact. And lastly, isolate the problem. Unplug everything and just test one module at a time. Let's move to this next point and see how this all builds to a really important realization. Breadboards are fantastic for sure, but they are temporary test tools. You absolutely must graduate from the breadboard when your project requires precision analog accuracy, when you're pushing high current, or when you're running high-speed communications like SPI. A modular system, a perf board, or a custom PCB is just straight up required for long-term stability. Which leaves us with this final thought for today. Take a look at your current project. If it's been sitting on a messy breadboard for weeks and you're constantly fighting random glitches, weird resets, or intermittent failures, well, is it really a software bug, or have you simply outgrown your breadboard? It might just be time to fire up that soldering iron and graduate to a permanent solution. Thanks so much for joining me on this explainer, and hey, happy prototyping!